Welcome back, dear students. Under Algebra and Number Theory, we are in unit number 5, Classical Theorems and Multiplicative Inverses. In that, we are now in lecture number 8, which is about Euler's theorem problems. So earlier we had seen 7 lectures. So the first 3 was for Wilson theorem, followed by Fermat's theorem 4, 5, 6. And 6, 7, 8 is for Euler's theorem. So 6th lecture was about the statement and proof of Euler's theorem, and we are going ahead with the problems of Euler's theorem. So let's get on to the presentation. So let's have the first problem. So as I told you, phi, this phi is called as the Euler phi function. Also there is another name for it. It is called as torsion function. Okay, so it's a very simple problem, but the basic idea is quite important. So they are asking you to find phi of 1105 and phi of 7 factorial. Two different journals. Solution. So how do I start? So first let's sort out for 1105. So 1105 is definitely not going to be a prime number. We have the factors for it. So I'll try to factorize it. Just have a look at the where I'm highlighting. So 1105, when I factorize it by 5, I'll be getting 221 and 13 times of 17. So now there are 3 factors here. 1105 is equivalent to 5 multiplied by 13 into 17. So now phi of 1105 can be written as phi of 5, okay, and phi of 13 and phi of 17. Now after observing this, after factorizing and after splitting it, now I will check whether the given function or the given phi of that particular value is a prime number or not a prime number. Either of two cases I landing up. One either with a prime number or not with a prime number. So now if I'm going to check out, 5 is a prime number. 13 is also prime number. 17 is also prime number. So now we know that if P is prime, phi of P is equal to P minus 1. That is the result. So now phi of 1105 is equivalent to, the first number is 5, right? 5. So I can write it as 5 minus 1. Second number is 13. So I'm writing it as 13 minus 1. Third number is 17. So I'm writing 17 minus 1. Why am I doing this? Because they are all just prime numbers. So what is the value of this? 5 minus 4 will give you, 5 minus 1 will give you 4. 13 minus 1 will give you 12. And 17 minus 1 will give you 16. So the product of these three numbers is equivalent to 768. Okay. So the answer for the first part of the problem is completed. So 7868 is my answer. Now let's sort out for 7 factorial. Before taking the phi function for 7 factorial, let me find out the actual value of 7 factorial. So what is the actual value of 7 factorial? 5040. So how to split up this very huge number 5040? So I will use the canonical decomposition as you have earlier studied. So 5040 is a number which is divisible by 2 and just getting decomposed till 9 or till 3 square. Till 3 it's fine. So now how can I write it? 2 raised to the power of 4, 3 raised to the power of 2, 5 and 7. Now phi of 7 factorial. Now I'll operate the torsion function. Phi of 7 factorial is equal to, taking phi to the individual product terms, phi of 2 raised to the power of 4, phi of 3 square, phi of 5 and phi of 7. Here I could see 7 is a prime number, so I can simply write it as 7 minus 1. And 5 is also prime number, I can just write it as 5 minus 1 as I did earlier in the case of 1105. But whereas when coming to the first two terms, I'm having a term which is having raised to the power something. So here the power is different and here is also different. So whenever I have in the form p power k or a to the power of k, then it will be a to the power of k into 1 minus 1 by k. Clear? So now 2 raised to the power of 4, I'll write it such into 1 minus 1 by 2. And how will I decompose this 3 square? So I'll write 3 square into 1 minus 1 by 3. So now finally 1 minus 1 by 2 is half, and 1 power of 2 will get cancelled. 1 minus 1 by 3 is 2 by 3, and 3 and 3, 1 power will get cancelled, and 2 is there, so 3 into 2. And 5 minus 1 will give you 4, and 7 minus 1 will give you 6. The product of all these numbers results in 1152. So this is how we end up with the problem. So we move on to the second problem. Find the remainder when 245 raised to the power of 1040 is divided by 18. So now we have to find the remainder when 245 raised to the power of 1040 is divided by 18. So now what is the value of A? A is 245. We see that A is not a prime number. So we got to factorize it, and we have to find the factors of it. So 5 into 7 square. So 5 times of 49 gives you 245. So now you could see that 18 is not a prime number. It's a composite number, and I could find the values of that particular 18. So particular 18, if I'm going to factorize it using canonical decomposition, I'm landing up with 2 into 9. So 9 can be written as 3 square. So what is that? Therefore, A comma M is equivalent to M. That is the relatively prime numbers. Hence, by Euler's theorem, A raised to the power of phi of M is congruent to 1 mod M. So 245 raised to the power of phi of 18, M value is 18, is congruent to 1 mod 18. So let me simplify this phi of 18. So in the previous problem we had done what we used to find the torsion function. Phi of 18 is equivalent to phi of 3 square into 2. This is how I splitted this 18. So again I'm going to take the 5 operating phi of 3 square into phi of 2. So phi of 3 square can be written as 3 square into 1 minus 1 upon 3. And phi of 2 can be written as 2 minus 1, that is 1. So 1 minus 1 by 3 will result in 2 by 3, and 1 power of 3 will get cut, and it will be landing up 2 into 3, which is 6. So 246 raised to the power of 6. This is how you try to eliminate that torsion function. So find out the torsion function first and operate it as a 2 marks problem, and then simplify it and get the actual power. Right? So finally, I am getting it as 245 raised to the power of 6 is congruent to 1 mod 16. This 6 is very far from 1040. So what will I do to approach 2040? Let's see in the next slide. So 245 raised to the power of 6, the whole power of 173. So how did I get this 173? I just factorized this 1040 by 6. Right? So if I'm going to factorize or divide this by 6, I'll be getting the quotient. Always take the quotient. So 6 into 173 will result in 1038, which is very much closer to 1040. So the remaining number is just 2. So 245 raised to the power of 1038, which is congruent to 1 raised to the power of 173, will result in 1 itself. So 245 raised to the power of 1040 is equivalent to 245. 1038 plus 2 is equivalent to 245,038. So 245 raised to the power of 1038 into 245 raised to the power of 2. So 245 raised to the power of 1 is easy for us to calculate first. So when I'm going to divide it by over 18, my remainder is 11. So then I will raise to the power of 2. So 245 raised to the power of 2, which is congruent to 11 the whole power 2. So 11 square is 121. So again, if I'm going to divide it by 18, my remainder is 13. So 245 raised to the power of 2, value is 13. And this value is 1. So 1 into 13, mod 18. So 1 into 13 will result in 13. So therefore the remainder is 13 when 245 raised to the power of 1040 is divided by 18. Hope you understood. Thanks for watching. We'll continue in the next lecture.